The next transformation is still a and b, but it's a version of a and b where they're negative. And so the key thing you're looking for is that if the negative is out here, what does it affect? If the negative is in here, what does it affect? So for me, anything in the bracket with x is going to affect the x values. So when this b value is less than 0, it's a reflection of the x values across the y-axis. So if you took a point here, like let's pick a point like 4, 2, and you make the x value negative, it's going to reflect the x value across the y-axis and give you a point at negative 4, 2. If it's the a value that's negative, it's a reflection of the y values, and then they're going to go across the x-axis. So for example, if you had a point 4, 2 again, and you times the y value by negative 1, you're going to get a point down here at 4, negative 2. And that's it. So now let's practice the types of questions that the textbook asks you. So the first one is describe how the graph of a function can be obtained from one of the base graphs, then write and then graph the function. So step number 1, we are going to start with y equals the absolute value of x. To graph the y equals the absolute value of x, we do a table of values. Now hopefully again you've got that idea of what the absolute value of x graph looks like. I'm going to pick values like negative 2, negative 1, 0, 1, and 2, which is going to give me the y values 2, 1, 0, 1, 2, because the absolute value just makes everything negative positive and everything positive stays positive. So then I'm going to sketch it. Now I'm going to sketch more points than I actually found because I know that it's a linear graph with a slope of 1 and that all of the x values equal all of the y values just in a positive direction. So ideally I have a ruler because then I don't need so many points, but it's going to look something like this. Oh, this is so hard. Backwards. Oh, not bad, not bad, not bad. Yeah, not too bad. And then what we're going to do is we're going to transform it. So what are we going to do? Well, we are going to reflect which values? Well, the negative is not in the bracket with the x, so this is going to be reflecting the y values, and they're going to go over the x-axis. Now, if you want to know specifically how we're going to do it, we're going to do this by multiplying the y values by negative 1. So if we go to a new table of values, again, we know that this is a transformation on y and not x, so we can keep all the x values the same. But what's going to happen is all the y values are going to get multiplied by negative 1. So we get negative 2, positive 2, no, negative 2, sorry. I confused myself there because I looked at the y values and then I did it, and then all of a sudden I got confused by looking at the x values. So it's going to be negative 2, negative 1, 0, negative 1, negative 2. Why? Well, because if I put in an x value of negative 2 into this new function, I get the absolute value of negative 2 is positive, but then that negative is going to make it negative. Okay, so this is a transformation on y because it happens after all the operations have happened on x. So my new graph is just going to take all the y values and reflect them across the x-axis. So I'm going to get this V shape, but opening down. Awesome. And again, in case just to keep the same kind of pattern going, to look at these transformations of reflections, to reflect the y values, the key thing is that the whole entire function has to be negative. So if you have even some giant expression like x to the 5 plus 3x squared minus 1, if you put a negative out front, so let me just copy this, right? If I was to put the negative out here, it's going to reflect the y values so that it goes over the x-axis. If I was to take this again and instead of putting the negative out front and I put it individually with each of the x's, this is a reflection of the x values over the y-axis. So can you see the difference? So this one, we're looking at the red graph as our base graph, and then this purple graph reflected the x values because the negative was with the x, and it went over the y-axis. So now, as always, we do a description and then we write the equation and so on and so forth. So for this one, what are we starting with? Well, again, we're going to start with y equals the absolute value of x. Now I've gotten lazy. Instead of writing start with, I'm just saying number one. Number two, what are we going to do? Well, this is going to reflect which values. Now it's in the bracket with x, so it's going to reflect the x values over the y-axis. And if you just want to write that, that's fine. If you want to put more, you could say by multiplying the x values or coordinates by -1. You know, you can be as wordy as you want. I find the more of these you do, the less words you'll write. But when you're first learning it, it is really good to see, like, what am I doing? Oh, I'm multiplying the x values by -1, which then reflects the x values over the y-axis. All right, pause the video, give this one a go. This one, we're starting with the absolute value of x. Now, did anybody get confused about this one? I threw them both in. Why not? Right? What is happening to this graph? Well, it's going to be a reflection. So you're going to reflect the y values over the x-axis. And maybe even just put like a little like, hey, y times -1. And then you're going to reflect the x values over the y-axis. Take the x values and multiply by -1. And some people get lazy even more, and they're like, I reflect over the x-axis, I reflect over the y-axis. I really do like starting with which values I'm reflecting and then which axis I'm going over. It just helps my brain. But you know, if you don't need it, you could just say, what am I going to do? Oh, I'm going to reflect over the x-axis, I'm going to reflect over the y-axis. Done. All right, let's try the equations. So this is going to be the shape of y equals the absolute value of x, but it's going to be reflected across the y-axis. There you go. The textbook always likes to take corners. So if you're going to reflect over the y-axis, is it going to be the x values or is it going to be the y values? To reflect over the y-axis, it's the x values that are reflecting. Next one, we've got the shape of y is equal to x cubed, but we're going to reflect across the x-axis. So which values is it going to be? So if you're going to reflect across the x-axis, it's going to be the y values. So for this one, you could just put the negative out front. Awesome. All right, and then we go on to trying to transform piecewise functions. So let's start with just a point. So if I have a point 2, -8, on my original graph and I transform it, what's it going to look like? Well, this is going to be a reflection of the x values. So I'm going to times the x values by -1. So my new point would just be -2, 8. Whereas if I put the negative out front, this is going to be the y value times -1. And my new point would be 2, -8. So now if we're going to transform a base function, key thing is we need some key points. So for this one, I would pick here, here, and here. So just 3 key points. I have a point at 1, 0. I have a point at 1, 2, 3, 2. And I have a point at 5, 0. What am I doing with this one? This is going to make me multiply the y values by -1. And this is going to make me multiply the x values by -1. So this is going to be a reflection over the x and the y-axis. So multiply both values by -1. And I would get -1, 0, -3, -2, and -5, 0. So my new graph is going to be over here, -1, 0, -3, -2, and -5, 0. So it's been reflected across the x-axis and across the y-axis. And it wouldn't matter which order you did them in. Like if you wanted to do it one at a time to see it visually, you could reflect it this way and then over, or you could reflect it over and then over. Awesome. All right.